Hello machine learning gang, welcome back to my YouTube channel. Please make sure you click the subscribe button and the like button. Make sure you share this video so that we can reach as many people as possible. So today we will be creating our first neural network using keras and the TensorFlow library. So the first step is we are going to look at the 5-step model lifecycle. So when we are developing deep neural network, the 5-step model lifecycle is first we need to define our neural network model, and then we need to compile it, and then we need to fit the model to the training set, and then we need to evaluate the model if it's performing well or not. And then the last step is to make predictions using the model. So the first step is I'm going to import NumPy, which is a mathematical library. I'm going to import TensorFlow, and then from TensorFlow I am going to import keras, and then from TensorFlow.keras I'm going to import the layers, and then I'm going to import pandas read CSV, since we will be using the Pima Indians diabetes dataset. So to read that CSV file, we need the pandas library. And then we are going to use from sklearn module selection, we are going to use the train test. And then we are from sklearn, we are also going to import the pre-processing library. So here I have the path for the dataset. I will provide the dataset in the GitHub repo. And then so the first step is we need to run our dependencies, and then read our file from our path, and then the dataset has the following features. We have the number of times pregnant, plasma glucose concentration at 2 hours in an oral glucose test, tolerance test, diastolic blood pressure. We have the tricep skin fold thickness, 2-hour serum insulin, body mass index, diabetes pedigree function, and also the age. So these are the features we are going to use to predict if the person has sugar diabetes or not. So this is a type of a classification problem. So the next step is we need to visualize our dataset. To visualize our dataset, we use the dot head function from pandas library. And then we are going to split our values into the x and y. So here for the x value, we are going to take all the values except this last column, which contains our labels for if the person is 1, if a person has diabetes, 0 if the person does not have diabetes. And then for the y, we are not going to check anything. We are just going to take this last column which contains the labels. And then in the next step is we are going to split our data set into the training set and the test set. So I'm going to talk about the training and test set in the next upcoming video. So we are going to split our data set into the training and the test set. So we want our test set size to be 33% of our entire data set. And then the next thing is we print the shape of the X-train shape, X-train dataset, X-test, and then Y-train, and then Y-test. And then number of features, we are going to say that the number of features is going to be X-train dot shape as the shape of the column, of the whole column, right? And then we have 8 features, right? And then the next thing is we are going to scale our dataset. We want our dataset to be in the same range. As you can see here, we have a dataset with 148, 72, and then we also have datasets with decimal points. So we want our dataset to be in the same range so that we do not confuse our algorithm. So what we use, we first transform our dataset, and then we use the pre-processing standard scaler, and then we feed our dataset. We feed the train set, and then we feed the test set. So in the next here we have the diagram of a neural network that we are going to create. So we have an input layer, and then we have the hidden layer with 4 hidden units, another hidden layer 2 with another 4 hidden units, and then we have our output layer with just 1 hidden unit. So in this case, we are not going to have 4 input layers. but we are going to have 8 input layers since our input features is 8 inputs. So we are going to have 8 inputs and eight hidden units in the input layer. We then have four hidden units in the hidden layer 1, 4 hidden units in the hidden layer 2. So now this is how we define our module. Remember, I said that the first step is we define our module. So this is how we define our module in keras. We say module is equals to keras.sequential. So what we are doing here, we are just telling keras that we are going to be declaring our neural networks in a sequence, right? And then the next step is then use the module.add. Now we are telling keras that we want to add a layer of the dense unit. So here we provide layers.dense. In the dense class, we then provide the number of hidden units. In this case, you can see we have 4 hidden units. We then provide 4 hidden units. And then the activation function for our neural network, we are going to use the ReLU activation function. And then we then provide the input shape of our neural network as the end features that we derive from here, which is 8 hidden units in our input layer. And then in the next step, right, as you can see, we have created this first hidden unit. And then the next step is we now create in a sequence. As you can see, we are doing it in a sequence. That's why we declared module is equal to keras.sequential. So this is how we define our module, right? So the next step is we now need to add this hidden layer too. So now what we do is we say module.add layers.dense. We add 4 hidden units. Our activation function is the ReLU. And then now for our output layer, this is a binary classification problem. So since this is a binary classification problem, we use our activation function as sigmoid, right? So we are going to say modules.add layers.dense. We have 1 hidden unit, as you can see here. Our activation function is the sigmoid. So what the sigmoid does is, if let's say our output is less than 0.5, it's classified as 0. If it's more than 0.5, it's then classified as 1, right? So now we can run this sequential code, and then we can even run this module.summary. So what this module.summary, this summary function does is it brings a summary of our neural network, right? As you can see, we have the dense with 4 hidden units. It has 36 parameters. We have another dense layer, the second one, with 4 hidden units, and then we have 20 parameters. As you can see, our module has total parameters of 61 and trainable parameters 61, non-trainable is 0. So the next step is, as you can see here, from our 5-step module lifecycle, is we need to compile our module, right? So what we do is we say module.compile. We use the compile function. In the compile function, we then provide the loss function. Since this is a binary classification problem, we use the binary cross entropy loss function. The optimizer, we use the popular Adam optimizer. And then our metrics just need to use the accuracy metrics. I hope this is familiar to everyone. We need to test the performance of our module using the accuracy, right? So the next step is we need to fit our module into our dataset, right? So we use the module.fit function. We then provide the X-scaled train set here that we created here. X-scaled train, right? We now provide the X-scaled train. We provide the Y train, right? We also provide the Y train. And we also provide the Y train, which are labels, right? And then we then provide another parameter, which is epochs. Number of epochs is equals to 1. So what are epochs? So epochs is just one cycle of forward propagation and then backward propagation. So if you perform one forward propagation and one backward propagation, that's one epoch. So in this case, we need 150 epochs, right? So now we are going to provide we are going to feed our neural network data we're going to feed the data in our neural network in batches, right? So we want our batch size to be 10. So now what's going to be going to divide our data into 10 batches, right? So we feed our neural network in a data set in batches, right? And then we use the validation split, right? So what the validation split does is that from our training set, right, we'll split 20% of the data set that will fit into our training set into the validation into our validation dataset or the developing dataset. So what is the validation dataset? The validation dataset is the dataset that we need for us to judge the performance of our algorithm. It's the dataset that we need to tune our module, to fine tune our module hyperparameters, right? So after that, what we need to do is after that we feed the module. As you can see now, it's running now Epochs. As you can see, we have the loss. As we can see, as we start, the loss is high, but as it goes on, the loss is reducing. As you can see, the accuracy is 64, and then it's increasing up to, it has increased up to something like 80%, right? And then we also have our validation accuracy also increased up to 74%. So as you can see, the accuracy of our module increased as time goes on. As we trained our module on our dataset, the module was getting familiar with the dataset. But this module is not performing well, right? We'll take a look into future videos on how we can improve this module. But as for now, I just wanted to see how you can create your first deep neural network using keras and tensorflow. So the next step is we need to evaluate our module, right? So as you can see, we have evaluated our module. As you can see, the accuracy is 37%. Our module is not doing well at all. It's not doing well at all. So what we need to do is we'll need to fine tune our module in the future videos, right? I'm going to teach you that. So the next thing is we need to predict our module. So what we need is we need to predict with the data that our module hasn't seen. Since guys, remember that as we are developing these neural networks, we are developing these neural networks so that our neural networks can predict real-world data, right? So we need, when predicting data using our neural network, we'll predict with real-world data, right? So guys, this was my video on how to create your first neural network using keras and TensorFlow. So if you enjoyed this video, make sure you click the subscription button so that you do not miss any of my videos. And also click the like button, guys. You know, you are programmers, guys. You know how this YouTube algorithm works, right? So you need to make sure that the YouTube algorithm pushes this video so that we can help more and more people. We can create a community of machine learning engineers, right? So stay safe, machine learning gang.